Good morning, students. Welcome back to PTSP online class. So, with the 3 classes, the fourth unit will be closed. And we have been discussing the stationary processes. The stationary processes is nothing but a random process is said to be stationary if its all statistical properties such as mean, moment, variance, autocorrelation, cross correlations does not change with the time shift. So that means what? We have a random process in which we will be choosing a sample space, and at one particular time, if there will be the time shift, if the properties of that sample does not change, then that is called a stationary random process. If the statistical property changes with, if the statistical properties changes with the time shift, then that is called non-stationary random processes. The definition of the stationary process is that a random process is said to be stationary process if all its statistical properties does not change with respect to the time shift. The stationary process which depends on the density functions. So in the earlier classes we have discussed about the various types of density functions, that is like first order density functions, second order density functions, nth order density functions we have discussed. With respect to these various levels of density functions, we should go with the stationary processes, like first order stationary function, second order stationary function, and the nth order stationary function, and likewise we will be having. Then I am going with the first order density function. What our intention is to discuss first order stationary process. That means what? When we apply the concept of stationary process to the first order density function, then that will be first order stationary process. First going with the first order stationary process. A random process is said to be first order density function, and it does not change with the time or the shift in the time value. That means what? We have a density function fx, and it is chosen at the random value we chosen at the time, that is t1. If there is a time shift in the t1, if the density function does not changes, then that is called as it is a first order density function. It is very clear. We have a random process in which the sample is selected at the time t1 and the sample is called as x, and we will be having the same density function even the time is shifted. That may be positive or negative. If the density function remains same, density function does not change with respect to the time shift, then that is called first order density function, because first order stationary process. Why we are calling it is first order only? Because we have chosen only one sample from the random place. We have chosen only one sample from the random process at one particular time. If we chosen with the two samples x1 and x2 are at the two time intervals t1 and t2, if that density function does not change with the time shift, then that is called second order density function, second order stationary process. If the second order joint density function does not change with respect to the time shift, then that is called second order stationary process. So I am concluding this one. Here definition, the first order, we have the random process, in which we have chosen x is a sample at the time t1, so that which has the density function fx of x of t1, x comma t1 will remain same even the time is shifted. Fx does not change with respect to the time, so that we can call it is a first order stationary process. This, if the x of t is a first order stationary process, when we can have this is this one, if x of t is a random process and here the time is delta, it is a delta t. Therefore the condition for a process to be a first order random process is that mean value must be constant. That means what? Without shift the time, without shifting, without having the shift, that is having the fx of x of t1, that is a density function. For that density function, we will be calculating a mean is a, assume that. Even having the time shift also, we will be calculating the density function, that is fx of x1 comma t1 plus delta t. For this also we will be calculating the mean. If both the mean will be same, even we are having the time shift, the both the mean is same, then that is called first order stationary process. Mean is same means what? Here we will be going with E can be represented as it is a mean. E of x of t. X of t is nothing but what? It is the random process. Mean of x of t is equals to x bar, and x bar is nothing but after having the time shift. If both are having the same mean, then that will be the constant only. Even if you are changing the time shift also, there is no difference, so that it will be constant. Then that is called first order stationary process. In similar to this, we can define the second order stationary process. That means what? We have the random process x of t. We have a random process capital X of t, in which the two sample space we have been choosing x1 and x2, and two instant of times t1 and t2, and the density function is given by choosing the two samples from a same random process, and we will be having the density function is fx of x1 comma x2, and at the two instant of times t1 and t2, so that it must be equal to even with the time shift also, because what? Fx of x1 comma x2, but this time is shifted to t1 plus delta t. Delta may be positive or negative. t2 plus delta t. That means what? That the density function remains same even the time is shifted. With the two samples. What are the samples now? x1 and x2. In earlier case, only we have x only. Now we will be having the two samples, that is x1 and x2, so that fx of x1 comma x2 chosen at t1 t2 and shall be equals to fx of x1 x2 and t1 plus delta change, t2 at delta change, and this, if this satisfy this condition, that is called second order stationary process. So that I will be giving the definition. A random process is said to be stationary to the second order if its second order joint function, if it is second order joint density function does not change with the time or a time shift value. We know that this is the condition. So here that is fx of x1 comma x2 chosen at t1 t2, which must be is equal to fx of x1 comma x2 t1 plus delta t, t2 plus delta t for all the time, for all t1 t2 values, that is delta. It is a function of time difference and not absolute time. That means what we can define here, the function of autocorrelation function of t, that is named as it is tau. Tau is equals to, we know that it is a time difference only, that is t2 minus t1. This density function is purely dependent on the time difference only, that is t2 minus t1. That in our convenience, that difference we will be calling it is t2 minus t1 is calling it is tau. Note that a second order stationary process is also a first order stationary process. We know that if it is satisfying the second order, if it is satisfying that fx of x1 comma x2 chosen at t1 t2, even though that is having the time shift, if the density function remains same, means it is a combination of two first order density functions, so that here the point is to be noted that a second order stationary process is also the first order stationary process. It is also the first order stationary process. The condition for a process to be second order, that is, the autocorrelation should depends on only the time different, not on the absolute time. That means what? Here the density function should dependent on the value of t. That means what? It is a combination of t2 and t1. It is not dependent on individually t1. It is not dependent individually on t2. So that the density function should dependent on only the joint density function should be dependent on only the time difference, not on the absolute time. So that here this is dependent on the t2 minus t1. That process is named as second order stationary process. If you are choosing the two samples from the same random process, then that is nothing but it is a autocorrelation. It is a autocorrelation. In the last class we have discussed it is autocorrelation. When the two samples are defined in the same random process, that is called autocorrelation. So that autocorrelation, this autocorrelation is denoted with like this: Rx of x and chosen at t1 t2. This is the first sample space, this is the second sample space. First sample space chosen at t1, second sample space chosen at t2. Then that will be is equals to E of x1 comma x2. That means what? This is E of x1. Earlier we have what? Earlier we have only one sample space, so that we have E of x of t1, E x of t2, and here this is what we can call it is a autocorrelation function. This is R of x of t2 t1 t2, x of R of x of t1 t2, that is called it is a autocorrelation function. And this autocorrelation function, we know that it is dependent on tau. Tau is nothing but what? It is the time difference which can affect the second order joint density function. So here if we convert this is into another form of equation, Rx of x, and it is t1 is same and t2 is shifted. T2 is nothing but I can call it is t1 plus tau, because here t2 I can write is what? From the equation tau is equals to, I can write tau is equals to t2 minus t1. I can write t2 is equals to t tau plus t1 I can write. So that I can rewrite this equation: Rx of x at t1 comma t2 can be written as tau plus t1. Tau plus t1 we can write tau plus t1, so that here it t1 remains same, here t2 will be tau plus t1. It should be independent of time. This should be absolutely independent of time. This is called a second order stationary process. And the third one we will be going, that is third one, it is nothing but a wide sense stationary process, and we can call it is a wide sense random process. Means we can denote this is wide sense stationary process, that is WSS. Whenever you see the WSS, you should understand that it is one particular type of stationary process, that is nothing but it is a one particular stationary process, that is nothing but wide sense random process. Wide sense random process, this is about within the same random process, and this is going to be is two different random processes. Then I'll be going with this one. If a random process x of t is a secondary random process, then it is called a wide sense stationary or weak sense stationary. However, the converse is not true. The condition for a wide sense stationary process, we will be going with the condition for the random process will be two types, and the WSS is nothing but what it is, a wide sense stationary process. There are two conditions has to be satisfied by the random process, the stationary process, then only we can call it is a wide sense stationary process. This is about first one. It has to satisfy the first order stationary process. This one condition is what? E of x of t is equals to x bar, it must be constant. And second one, it has to satisfy the condition of second order joint density function. And after that, this has to satisfy the two condition. After that, we will be going with the cross correlation. That means what? This we wanted to define x of t. We have to define x of t is a wide sense, capital X of t is a wide sense stationary process, so that we will be going with the cross correlation. First, it has to satisfy the two condition. Third must be, we will be defining x of t with respect to the y of t. It is another random process. We will be choosing one sample from the x of t, another sample from the y of t, so that the cross correlation, it is between the two different random processes. Earlier, it is between the two samples are from the same random process, both are x only. But here, one random sample is from a random process x of t, another will be from the y of t, so that x is sample at t1 from the x of t, y is a sample at t2, that is at x of y of t. Then it is a cross correlation. It is nothing but e of x of t1 comma y of t2. This is called, it is wide sense stationary process. Joint wide sense random process, that means what? If you go with the two types, that is this is called this particular thing. If it is satisfied, this is simply you can call WFAS. If satisfy all the three, we can call it is a joint. We can call joint wide sense stationary process. So if it satisfies the three conditions, then that is called as it is a joint wide sense stationary process. This is about the three stationary processes. With the fourth one, this stationary process will be closed. It is very, very important in the examination point of view. This is the fourth one, that is the strict sense stationary process. You should go with the definition of each and every process. The stationary process is nothing but if all the statistical properties of a random process does not change with the time shift, then that is called it is a stationary random process. If the statistical properties changes with respect to the time shift, then that is called as it is a non-stationary process, non-stationary random process. And we will be going with the last one, that is about strict sense stationary process. Strict sense stationary process is very simple, that We have the random process. We have the random process x of t, in which we will be choosing the samples x1, x2 and up to xn. We will be choosing at the various values of the time, that is t1, t2 and tn. If this joint distribution, if nth joint distribution function, if nth joint density function, that is fx is nothing but x comma x1 comma x2 comma up to x of n, and will be chosen at t1 t2 like that it has, so that if this density function does not change with the time shift, then that is called, it is a nth order joint density function. I am defining now a random process x of t said to be strict sense stationary, we can call it is triple S. Yes, strict sense stationary random process. A random process x of t is said to be strict sense stationary if its nth order joint density function does not change. The joint density function does not change with time or time shift value, then that is called as strict sense stationary process. Fx, x1, x2 up to xn, and these are having the t1, t2, en, and is equals to fx of x1, x2 up to xn, and there is a time shift is at the each instant of time. Even having the time shift also, it does not change its density function. That means all the statistical characteristics like mean, correlation and the variance and the modes of operation does not change with respect to the time shift, then that is named as it is a strict sense stationary processes. This is so a process that is a stationary, if a process that is a stationary at n is equals to 1, 2, 3 up to n, then that is called, it is a strict sense stationary process. Note that strict sense stationary processes is also a wide sense stationary process. We know that wide sense is for the two samples only, and two samples and can be, one is from the one sample space, one random process, another is from another random process. So that note that the strict sense stationary process is also a wide sense stationary process, but the reverse is not true. That means what? The wide sense stationary process is not the strict sense stationary process. This is the point you have to remember. With this, all the random processes, various random processes are completed. With this, the almost 60% of the fourth unit is complete. Then I am moving with in the next class I am going to talk about the another topic, that is about some of the various functions. So far we have discussed the various random processes. In the coming class, in the next class, I am going to talk about some various functions.